Hello everyone, this is Jinchen, a PhD student from Beijing Institute of Technology. I'm very glad here to share our recent work with you, meta-causal learning for single-domain generalization. Existing methods focus on expanding the distribution of the source domain to cover the text domains, but without estimating the domain shift between the source and text domains. We propose to learn to analyze the causes of the domain shift and then learn to reduce the domain shift according to its causes. In this paper, we propose a new paradigm, namely simulate, analysis, reduce, which first simulates the domain shift, then learns to analyze the causes of domain shift, and finally learns to reduce the domain shift for model adaptation. Under this paradigm, we propose a meta-causal learning method that have four components: a data transformation model to generate auxiliary domains as text domains, a counterfactor inference model to discover the causes of the domain shift, a factor-aware domain alignment model to reduce the domain shift, and a Bayes model for feature extraction and classification. To make the simulated domain shift as realistic as possible, we define variant factor sets to represent extrinsic attributes of data, such as the variations of brightness, viewpoints, and color. For each variant factor, we construct a data transformation function. Given source sample, we randomly sample multiple variant factors to generate auxiliary sample. From the console graph, we can see that ideally the cross-domain classification is only determined by the semantic concepts. However, in reality, the semantic concepts are unobserved from the input samples, so the classification should be implemented by learning the age x to y through ages v to x to y. The category node y is also affected by the variant factor node v. As the variant factors are domain-specific, their causal effects on the category lead to the domain shift. Hence, we infer the causal effects of the variant factors on the category prediction to discover the causes of the domain shifts. After analyzing the causes of domain shift, we propose a factor-aware domain alignment to reduce the domain shift by learning multiple feature mappings with guidance of the inferred causal effects of variant factors. We build an effect-to-weight network that converts the causal effects of each variant factor into the weight of corresponding feature mapping. The alignment of the source and auxiliary domains is implemented by minimizing the feature distribution between the source and auxiliary samples in the source feature space, as shown in the first term. The second term encourages the auxiliary samples to belong to the same categories as the source domains. We conduct experiments on the digital cvpr2023 PACS datasets. Compared with some advanced methods, our method has better performance. We visualize the inferred causal effects of variant factors for the unseen tagged images on the cvpr2023 dataset during testing. It is interesting to observe that the inferred weights of the noisy Gaussian variant factor are larger than that of the other variant factors, indicating that the counterfactor inference succeeds in discovering the real causes of the domain shift. We conduct ablation experiments on the PACS dataset. The results show the effectiveness of each component of our method. Okay, in summary, we have presented a new paradigm: simulate, analyze, reduce, which empowers the model with ability to analyze the domain shift instead of directly expanding the distribution of the source domain to cover unsyntactic domains. We have presented a meta-causal learning method that can learn meta-knowledge about inferring the causes of domain shift during training and apply such meta-knowledge to reduce the domain shift while boosting adaptation during testing. That's all. Thank you.